All right, well, thank you folks for joining us today. We're gonna have a presentation on a product called Durago Stream, produced by Maine Manufacturing Partners. And it's a bit of a different way to think about the costs and treatment of your sewer effluent through your sewer packages. It also has some green hydrogen energy opportunities for us in the future. And it has a real interesting step towards sustainability in most community operations. My name's Matthew Eddy. I'm the Executive Director for Midcoast Council of Governments. And speaking to you today will be Craig Cunningham from MMP, and he can introduce his team if he chooses, and we'll get started.
Okay, thanks, Matt. So Matt said I'm Craig Cunningham. With me is Bill.
Yeah, Bill DeSisto, University of Maine.
Don Newt, part of the manufacturing team.
Steve Doughton with part of the team.
Howard Carter, part of the team.
Amy Safford.
Team outnumbers the guests.
Yeah, we did well. Just you can.
Yeah.
Matt, you-
Okay, yeah, Mike Thayer, I'm with the Wallable Utility District. I'm also on the Town Water Committee.
Julie Kaiser, Town Manager, Wolfboro.
I'm Max Johnstone with Midcoast Council of Governments, hiding off in the back.
Couple more, right, Brad
Orion.
and Ryan?
Yes, yeah, Orion Thomas, Regional Planner with Midcoast Council of Governments as well.
Hey, everybody, Rhett Lamsley, planner in Rockland.
Okay. Just to give you a real quick overview, actually in a little more detail, you've got Sisto, who's a professor at the University of Maine, and Howard Carter, who is the actual director of wastewater recovery in Saco. And Amy has her own business besides being part of this, and communications and marketing. And you've got Steve Doughton, who's a general contractor, and Don Notes, who's a mechanical contractor. So a little bit of background about Maine Manufacturing. It was a business, we had a life science business for quite a few years. It was had two locations, one in Sanford, Maine, and one in Westboro, Massachusetts, and actually sold that business to a global company, and it still exists. That was, you say life sciences, there was a lot of filtration, membrane, and a lot of devices that are used in diagnostics. And for instance, if anybody's taken a COVID test, we would make nitrocellulose membrane that was similar to what's in a lot of those kits. So lots of things to do with water. And we've made the leap from that to this, which is a little bit different. And with the help of Bill and University of Maine, we've come up with a couple of things. When you look at this slide, which I'll open it up a little bit better if I can. Maybe, well, maybe not.
Slideshow.
Yeah, I just won't go to the full screen. My cursor's a little bit frozen, but it should work. So you've got Durago Stream that Matt talked about and that we're focused on at the moment. And what the technology is it comes, there's three products. We named them Durago Stream, Durago Clean, and Durago Hydro. So in this process, you take water. In our case, we can take turbid water. That was good you pointed out that Max might be drinking some chunks there and things. We can take turbid water and generate hydrogen, but more importantly, we can generate a really good disinfectant called hypochlorous acid. Different levels of different parts per million. We as human beings, we're all generating hypochlorous acid in our bloodstream today, right now. And it basically, from what we've done in the cities of Saco and Biddeford, has shown that, you know, it's real effective in killing fecal matter and pretty much everything in the waste stream. It also it has a different effect on the water because you're using some of the effluent to actually make the product. It actually, I'll quote a person from the Maine DEP that said it was, you got the regular bleach that people use at 14%. That's like a nuclear warhead. And this is more like a smart bomb. It kills what it needs to kill and doesn't just stay in the water. This is something that has a lifespan of about 6 months, maybe a little more or less, but and you generate it with a piece of equipment that we'll go into. So three things are coming out of what you'll see in those three products. Two based in hypochlorous acid, the other one's hydrogen. These slides don't want to move now, but there we go. And that's pretty much what we're going to talk, what we'll spend most of the time talking about. The next one gives you just a little bit of further background on the different waters you can use. In the case of what we've done at this point, it's been effluent with salt added that we'll get into. Finally, on this slide, it just talks about a little bit of the hydrogen that's produced. So to give you a little bit more, there we go. Just gonna stop this one and start the next one. Bear with me for a second. Sure, it's just me, Max, but just having a little bit of a hang up with this, even though it did
Max
go.
is a techno wizard.
Good. Just want to share now this one. So, go to Zoom. Yep. Oh, yeah, there we go. Okay, so just to give you an idea, everybody wants to know what causes this and how it's made. So this takes you through it. So you have three pretty basic components: the feedstock that we've talked about, which can be effluent. It can be municipal water, it can be well water, it can be seawater. So that's the feedstock, which then you add salt to it. I'm not sure who's you're probably familiar with turbidity in water. 10 is, it's definitely in water you don't want to drink. 10 NPU is probably similar to some seawaters. It's pretty packed with small debris, but it's got a fair amount of debris in it. So we take that water, add a small amount of salt to it that's getting smaller, and then add electricity to it. So the electricity is it's a pretty specific wavelength that people don't get into a lot with electricity, but that wavelength, which goes into a function generator, so you can adjust it up or down and get the quantity of electricity out to it, travels really, really fast at about 10,000 pulses per second. It can be direct current where you're just putting a constant stream into it, but it's traveling just like the water is through, if you can see where my cursor is, through this small reactor. The electricity is running in and going back around and back to this board that says MMP on it. Oops. And just cycling back and forth. So small amount of electricity can be large amounts of electricity, but it travels through that board, through a function generator, and into the water through this reactor that you're seeing there on the right. So now you've got a certain feedstock, you've got a certain amount of electricity running through the system and through the water. There's a small amount of filtration in it that actually separates the debris that we talked about, the turbidity, and the actual hydrogen that we produce when we're doing that. So these filters that you're seeing here are a basic hollow fiber filter that's got two types of membrane in it. One's able to separate only gas material. The other one separates liquids like we're all used to. So now you've taken the feedstock, you've put electricity through it, and now you're separating the gas from it. And now you've actually, and Bill will probably throw a few things more into this, but now you've got hydrochloric acid, which is the disinfectant that we talked about, or could be called Dirigo Stream or Dirigo Clean. So it looks just like water, acts like water. I've got some here that will run through, but it's actually changed by the electrical charge through it into a disinfectant that's a lot like that keeps us well as human beings. The other thing that you get is, this is just a picture at night showing the flame, but you get that as a off gas of the process, which when you think about it, I don't know. So Waterboro has their own system.
Waldoboro.
Well, yeah.
There is a
I've said that.
Waterboro.
I'm hooked.
I've worked in both.
I'm just hooked to Waterboro because it's in my area. Sorry about that.
I have the same problem with Kennebunk and Kennebec now.
Yeah, you can tell me anything, or the town I'm in from. So they have their own, you have your own treatment plant to a degree, right?
Yes, we have a water treatment plant and a wastewater treatment plant in this town.
So this disinfectant that we'll get into a little bit further can disinfect your waste stream nicely. People use it for drinking water treatment too, but we're not at that point. So from that, the system used to look like that. That was a mobile unit that we actually took to Howard's plant that's on the video, and the plant in Biddeford as well. Worked well, but really needed some changes, and the reactor had some issues, and filtration had some issues, but we knew, yeah, it killed all the fecal matter needed in a treatment plant at that point. Today, or this is in Boston a few months ago, the unit looks like that. This one has 2 reactors in it and probably would have the capability of our first pilot that we're doing in Biddeford Pool. But we've actually chosen to make it a little bit more effective and add some additional reactors to it. So the reactor that goes into Biddeford Pool will have, the unit that goes into Biddeford Pool will have 4 reactors in it. The complete system, this is just a real high-level flow diagram, but if you start in the upper left, it's got the effluent in, so that's effluent that's been processed, the solids have dropped out, those kinds of things. It goes through a turbidity meter into a small 65-gallon feed tank. From there, it's pumped over to the unit at the bottom, the Dirigo Stream unit that you just saw in the gray cabinet. And then the process that we've touched on goes through where you're running the electricity through it, and you're causing the reaction to give you Dirigo Clean. In the case of this is Dirigo Stream. And then it goes into this tank, this disinfectant tank. That's a 65-gallon tank too. It's written incorrectly there, but and then it's metered into the discharge pipe, and then it's chlorinated. We know that, and we know, and I'll show you what the DEP had to say about it from testing over the last, specifically over the last 3 months. So what's happening here is it looks bigger than it is, but in a small area, you're creating hypochlorous acid and hydrogen. The hydrogen in this case will be vented because we don't have a use for it at this point. And hypochlorous will sit there just like chlorine and disinfect their system or their discharge and keep it within line of what the chlorine does today.
What's the concentration of hypochlorous acid in the storage tank?
Yeah, the storage, it'll be anywhere from 1,500 to 2,000 parts per million. In the case of Biddeford Pool, you need about 24 gallons at their peak periods in the summer when the residents are there. 24 gallons per day at that rate that you just asked about. So the system will have the ability to create about 85 to 90 gallons a day, so that theoretically they would have it, they operate it remotely, they go there 2 or 3 times a week, but they would have 5 days that they would have before, if it broke down or whatever, before they would run out of the disinfectant. So pretty small system, taking effluent and creating hypochlorous acid, putting it into the system and effectively killing the fecal matter. Starting to utilize the, in the case of Biddeford Pool, that's a small system. I don't know what yours is.
About 150,000 gallons a day.
Yeah, so yours is larger. We do have those numbers, those types of capabilities too coming up, but it's a system that utilizes some of your water, like I said, before it goes to drain, and then creates the disinfectant and keeps fecal matter where you need it. And it's a lot easier on people. I don't know how you disinfect today. Is it through with chlorine?
Well, at the wastewater plant, we don't disinfect at all because is we have a lagoon system with spray irrigation and it's land applied.
Yeah.
At the water plant, we have sodium hypochlorite.
Bleach, or
Yeah,
it's 12.5% in that
Yeah,
range.
well,
right?
commercial laundry bleach is 5.25%.
Yeah.
So you're right, it's about 12 to
Yeah, it's a
15%.
little higher. So one of the big attributes of this is, of course, you can, an optometrist can sterile, not this made from effluent, but you can sterilize your eyes with hypochlorous acid. It's good on food and plants. And the long-term effects of what bleach has on people, because it is a corrosive, and equipment aren't nearly as destructive as bleach is. So do you want to add anything to that, Bill?
Well, I think you also have safety aspects, handling safety.
Well, hypochlorous acid is a solution of chlorine in the water. It's disproportionates. When you dissolve chlorine in water, it just disproportionates into chlorine, hydrogen chloride and hypochlorous acid. So it's basically a solution of chlorine in water. The vernacular term is, as you say, hypochlorous acid.
Well, there's chlorine in it, but it's not the same as sodium hypochlorite.
Well, sodium hypochlorite isn't chlorine. It's the salt of hypochlorous acid.
But sodium hypochlorite has a vast amount of sodium hydroxide in it.
Correct,
This does not.
correct.
That's probably the biggest thing. You got a corrosive at pH 13 down to a neutral acid that's at 7 or 6 to 7. So those lead to what Bill's talking about with safety aspects of, okay, if you've got a person that gets it in his eyes or her eyes, or those things don't
Understood.
happen.
It's 0.2%, 2000 ppm versus 13%.
Yep.
Which is a big difference.
Yeah.
It is much safer to apply it at 2000 ppm than it is to apply it at 15% for sure.
And if I can just show it to you right now. Sure, it's this computer, Max, but or me, but just kind of stuck for the moment. There, let me come out of it. Still not. Yeah, I don't want to share it yet. I just want to find it. It was kind of hung up there for a minute. Yeah, so we'll bring this up next. I guess it didn't work. Yeah, that's just trying to bring this document up. We'll go back to the. Yeah, there we go. Anyone's welcome to see if I can one of the things you can certainly look at this letter a little bit more. It takes you through what the DEP says and thought about the testing that we did earlier this year in Biddeford Pool. And takes you through probably the thing that we would focus on. It talks about EPA registration. But back to our just dialogue on bleach versus this. If I can bring it to the screen for everybody. And it just, they understood it as a valid alternative for disinfection versus chlorine or sodium hypochlorite. Just because of the test results that we had and how it killed the fecal matter and bacteria. So anyone's welcome to that. Back to again.
So Craig, as you're working through that, have you looked at the cost comparison? I mean, the cost of using a chlorine substance,
Yeah.
bringing in,
We have of course, it depends on, everybody's systems are different, but what we've looked at is that it's about, just to give it in general numbers, we would case by case, of course, do it differently, but it's about 50% the cost of chlorine. So one of the nice things, as Bill pointed out, you got the safety aspects, number one. Number two is you're able to generate utilizing your waste stream to effectively sanitize your waste stream. And then the cost is an improvement. And then you have a hydrogen platform to build off of. So in the case of, I think, did you say 55,000 gallons?
150,000 gallons.
Yeah. So you can look at that as there's a lot of hypochlorous acid in there. There's a lot of hydrogen in there, and it's an initial use for some of that water that typically goes to drain every day. With a sanitizer that's effective, but it also dissipates at a faster rate than sodium hypochlorite.
because I hadn't thought about this in previous conversations. Does it have application for lagoon systems?
Well, a lagoon system doesn't do disinfection.
Hmm.
And if the sole purpose of using either sodium hypochlorite or chlorine gas or hypochlorous acid is disinfection,
Mhm.
we don't disinfect at the wastewater plant.
So
It's
would that,
not discharged to water.
no, it's just sitting in the lagoon.
It sits in the lagoon, and then we store it over the winter, and then we land apply it. We use sprinklers
Yeah.
to sprinkle it on the ground during the summertime.
So you've been to Sanford, and they've got a lagoon system.
As does Thomaston, there are
Yep.
a number of lagoon
Yep.
systems in
Have you had yours long?
20 years,
Yep.
almost 20 years.
You're there, right, Howard? Was there?
Yeah, I'm there. Yeah.
And I'm not trying to say one system over the other. I'm just talking lagoon system, your system.
Right.
There's there are people, I think it's Oxford, that they don't they sanitize, but they filter it. Then there's UV sanitization. So there's a
Wide range.
There's a wide range, right? But he's right, a lagoon typically will just settle the solids in the pond and then minimally discharge, so he's land a plan, but whereas with us, we use sodium hypochlorite because we average around 2 million gallons a day, so quite a bit bigger than the other ones, but worked fine for us, worked very well.
So are there any other questions on just kind of the advantages, disadvantages, how we make it? There's things, I mean, I can hold them up if you want a better screen, but just, you can kind of visually see the size, the footprint, of a unit's pretty small, but and getting smaller. I guess probably the consumption of electricity that goes into it. We have those numbers laid out for you. There's just the total economics, those kinds of things. Anybody have any questions on those?
I'd like to know the energy consumption,
Sorry.
the energy consumption.
So it's gonna run in the range of 100 watts of electricity. Could be more, could be less, given the demand.
Well, I guess the best figure would be kilowatt hours per pound of chlorine.
We have those numbers.
We have-
in front of it, but we have.
Yeah, we have them, but probably one thing that might help. This is more on the hydrogen side of it. I don't want to mix this up because we are focused on the hypochlorous, but the hydrogen side of it gives you the exact amount of electricity, kilowatt hours, cost. I mean, the cost of electricity is going up right now, like everything else, but
We know. It's pretty pricey.
What we've done for the economics is basically look at the operating costs. It's the simplest way to do it. There's a lot of other things. Obviously, it's a complicated economic model, no matter how, because there's lots of moving parts. Prices change on different things. But we
And
looked at,
the scaling issue is going to be
and
huge.
scaling is big, so obviously scaling is in your favor.
There's a
but-
continuum from, 100,000 gallons a day treatment plant all the way up to 1 billion gallons a day treatment plant.
Right.
So there is a question of scale.
Right, but we're targeting from operating costs, if you look at replacing bleach, you pay for the bleach versus paying for electricity and salt. Okay. And we're targeting reducing bleach costs by at least 50%, at least cut them in half. So that would be, provide that savings, then of course that would be invested in the equipment. to Do that, right? You have to have some equipment. That's kind of, and that the numbers that we're seeing at these scales are about there. It makes sense. There's different ways to utilize the salt and electricity more efficiently, bounce one off the other. If you have cheaper salt, you use a little more salt, you use a little less electricity because your conductivity in the solution is better. So there's some different, there's a lot of fluid numbers there, but basically that's the goal, and that's our technology is there now. So whatever energy we're using to produce the chlorine, that plus the salt ends up being about half the cost of bleach. That's roughly
Exclusive of the capital cost.
not including capital.
Right, correct.
No, yeah, so, right, it's like you buy a solar panel, right? Your electricity costs go, electricity, when you start generating it, but you have to have the outlay for it, right? You save money.
Understood.
But that's, yeah, so there's factoring in capital costs starts to complicate things as well, at least in terms of where we're at.
Yeah.
But at the same time, it's the hydrogen. Hopefully, we're going to get the energy out of it at the same. same system, the whole thing.
Right, and we didn't include those costs in the utilities. We didn't
So
include.
that's why I said I would urge you caution with hydrogen. Well, flammable. The National Fire Protection Association recently, I want to say recently, probably 8 years ago, issued regulations for storage and use of hydrogen. They have books about that thick. It's intimidating. And of course, they were anticipating a hydrogen-based economy. I would get the books from the NFPA, and I can't give you the numbers now, but the NFPA has extensive publications on it. Right now, you're doing the right thing. Vent it outside.
Right.
Well, but right now, what they're proposing to do is not store it. It's to use it on demand.
Right.
Burn it off as it
Yeah,
occurs.
that's what makes it unique. That, yeah, you do go through the book, and a lot of the book is pressurization of hydrogen. So,
If you look at the NFPA documents, it's a series of what ifs. What if your flame goes out and the hydrogen is still flowing? If it's in a room, I'm not going to try to explain it myself, but I would urge you to get the book before you start touting it.
We've looked at those, and when we originally started out down the hydrogen road system, and it was doing well.
Yeah.
I agree with you. It's like that. It's any code book like that. It's like reading.
It's great, yeah.
A lot of storage, obviously, but I say that. We're doing it on demand. There's still a lot of regulations, and every time you do something, they'll make a new regulation for good reason. It's very flammable. It's very flammable.
But
For the time being, just
We're
well,
sticking with that.
put it in the air, put it back in the
so,
air.
so they've set up a pilot in Biddeford that the code enforcement officer and fire marshal's office were familiar with what they set up and how they set it up. And with the vent system, it's quite safe.
With event system, but
But it also can burn off at the same time, and it can flow into a number of different generators on demand. It's not the
yeah,
system you're contemplating in your mind.
part of it is listening to people like yourself and the documentation that's been done to this point, saying, okay, well, it's probably a great energy if you make it on demand versus you try to store it and transport it and those kinds of things. And that's what, that's what this has been about. But what we're trying to do is be focused on the hypochlorous, get it in there, know that it can save people money and be safer and a little bit better for the environment, and utilize something that we all as human beings throw away generally, and in the wastewater, and then know that, hey, at some point, there's a lot of hydrogen here that, if you can set it up and take full advantage of it at some point, then that's a great thing. If you can't, well, then you vent it like you say, and you go from there. But the actual disinfectant has, even us that are close to it, has been pretty impressive how it works. And the cost of it, as Bill mentioned, is pretty stout when you're a small municipality to start to save money. And not be held, if you think about it, I don't know if your chlorine's gone up lately, but I know a lot of people's.
well, it
have.
takes energy to make chlorine, so it's gonna go, if it hasn't, it already has.
Right.
And of
So-
course, people used to use gas chlorine to do wastewater, but no community ever wanted to store gas chlorine on its property. And even the big treatment plants that had tank cars of chlorine come in, they all switched to sodium hypochlorite.
Well, our colleague Howard had a good process not long ago, and he's got his hand up too, but I'll say what he said. People went from chlorine gas to chlorine, and what we hope is this is the next step to make it safer and more cost effective. Go ahead, Howard.
Oh, I think you guys are all missing one major aspect of this process is the resiliency. As we're all dealing with climate change, and everything else, if you have a big storm and you're cut off with your chlorine supply, your hypo supply, you're gonna have the ability to generate it right on site. So you gotta take that into account. But I guess in the big term and the long term, what I like about this process is even today, even though we're getting better as an industry, water and wastewater facilities still consume 3% of the entire power in this country. How neat would it be if we'd be able to be a few years down the road and generate all the power that you need to power your facility through the hydrogen and do your disinfection at the same time, and maybe even be at a point to power some of your municipal buildings. So I think I look at it as the long term. Yeah, the disinfection part of it's nice now. They could really save you some money and be able to do it on site, but looking at it long term. That's all I had to add, Craig.
Just to give you a quick look too, as far as scaling. So if you zoom in on this. So this is the one reactor that I'm holding in my hand. So you can scale it up by adding reactors, and the impact to, or the consumption of electricity isn't just triple, it's very subdued the way it works, but so you can get that reactor to produce 10 reactors this size to produce about 1 gallon every minute. So, so giving you as a, I won't say a real small, but a small scale user, the ability to say, okay, we're growing, the population's growing, the economic development guys built all kinds of businesses around here, and people have flocked in. Just kidding.
Well, they've got a business park that has some issues, so
Well,
it's
I'm
interesting.
originally from Caribou, so I like to dream too sometimes, but the way you do it is you add catalysts and reactors, and they're pretty, for whoever's left on the screen, they're pretty, that's what it was,
Based on plumbing.
Yeah.
You know,
they're a pretty standard
plumbing
looking
fittings and just,
device,
so
and electricity like in that
it's kind of a unique aspect of
PowerPoint,
it.
right, passes through it, and they work really well. And they're pretty easy to maintain, and there's nothing really to wear out in them, which is pretty, we don't talk about that much anymore either, but so it's taken a few years, but I can look you in the eye and tell you it's easily scalable.
Obviously, if they're modules like that, it's easily scalable.
Which we have.
And that's the way filters are too, you want a bigger filter, you just put a whole bunch of them in a row on a wall.
Yeah, but there's a big difference. Making filters a good portion of my life. Big difference between the cost of this and a filter. So.
Oh, polymembrane filters.
Yeah, because these are pretty inexpensive when they're completed. So, and easy to put in and take out of the actual generator. So that's a quick look at the scaling part of it.
Any other questions out there or comments from folks that are attending?
Anybody? I don't know if we still
Nope.
have. I believe we still have
Do you
everybody.
use any metallic components in the catalyst? If it's proprietary, I won't ask, but if it's like platinum or something like that, that could be pretty pricey.
Not flat.
Titanium based.
Yeah.
Titanium.
So this is. This is titanium, the water flows through it and the electricity.
No, it's
Amazing.
No, it's not platinum, right? No, platinum right away. Lay your hands right down. Yeah.
incredible machine job, I gotta say.
Incredible machining skills.
Yes.
That's great.
Oh, thank you. If I gain for nothing else. Yeah, the nice thing that's, I know Maine doesn't have the paper industry much anymore, but in earlier life, that's what I used to do is make equipment for pulp and paper, especially the pulp end of it. And then discovered titanium's impervious to most every chemical out there, especially in the paper industry. And what's nice about this is it reacts nicely with electricity, so.
So, this technology is in its development stages, I think is a fair statement. The model that they're working on in Biddeford Pool is a small treatment plant, but it's so far produced some pretty interesting results. The energy side of it is still the upside. If you could figure out how to run a treatment plant on its own energy, on its own flow, and not have to buy energy, you reduce your costs substantially.
This is not going to make energy. This is a net energy consumer.
I don't think that that's true.
I
The,
wager the contents of my wallet.
well, we'll take you up on that.
Everybody's wallet's important.
We'll take-
He's right. I mean,
Yeah.
you're using energy to make energy, so you can't make more energy. So that's, but it's gonna make energy.
Right,
So you get some energy back from the energy you use, rather than wasting it.
right.
That's possible. And if, I mean, we think long-term, we don't know the future, but, there's where electricity is coming from, how much it's gonna cost, et cetera. I mean, that, electricity becomes less expensive, for example, or there's more excess of it, different from renewables or different things. That you can convert that into something like hydrogen, which can have other uses and can be useful for other things. And hydrogen of itself doesn't have to be used as fuel, right? It can be used as it can be used in chemical reactions, can be used in other things that have higher value. So these are long-term things, but I think it opens up the possibilities and starting to think about. We've talked about this is wastewater treatment, becoming kind of a place where you generate resources, not just recycle things, but become sort of a generator. And those are long-term visionary concepts. But I think, it's starting to put some things together that enable that. I think we're pretty excited about that. Clearly, the hydrogen piece is going to need R&D work. It's going to need development work, to happen. But it's possible.
Another question. What's the voltage across the electrodes?
The voltage,
Yeah.
10, 12 volts for like that reactor. Maybe it could take more
And it can take less.
or use less, but in that range.
Well, it's a question of rate.
Yeah.
The higher over voltages give you a higher rate. If it's 10 or 12, I mean, this seems to be a great application for solar energy because the solar cells are producing low voltage power already.
Exactly.
Most solar panels, well, they're somewhere between 12 and 48 volts. And you can usually, even the 48 volt ones, you can wire them up so that they're 12 volts.
Yep.
And this would be perfect for that because you could run this intermittently during the daytime and you could store just a bigger tank instead of a 65-gallon tank of hypochlorous acid. You could have a 1,000-gallon tank of
We don't
hypochloric
have an
acid.
inverter or batteries or anything.
No
Solar
batteries,
panel,
no
correct, yeah.
inverter, correct.
Yeah, that's actually a good point.
We
Yeah.
run the complete system off a 12-volt battery, knowing that you could charge it. So charge it with a solar panel. We haven't introduced this to anybody in the solar industry at this point.
But to do like for Biddeford Pool, it might be just a small panel. You put a panel up and you just run it continuously off the panel. during the daytime and just run it.
You don't even need a battery, just build a bigger tank.
Right, and then your electric costs in the economic model go to zero. Well, you have an outlet for the panel, but it's just a panel, right? It's not a whole system.
Right.
Right, and then something to actually demo.
The
Yeah.
first one we looked at with Biddeford was utilizing the solar panels.
Mhm.
Yeah.
That's one of the reasons going to 12 volt, because it made it a lot easier, so. But yeah, it's a good point.
Yeah.
And we've come a long ways. What we're trying to do is get, this pilot going, get another pilot to go, and, go from there.
Do you have any materials other than this that you can share with me?
Yeah,
Or just some more brochures? Like I said, I'm on the water committee and we do use hypochlorite at the water plant.
Yeah.
And I could bring it up with the, town does not operate it themselves. We hire Maine Water to do it, which might be a fruitful avenue for you to approach.
main
because
water from Saco, they're in Saco
Yeah,
too.
same company,
Yeah.
same company.
Because you
I,
have to chlorinate potable water. before
Yeah.
Put it in a water main.
Yeah.
So they might be interested in it.
yeah, what we're looking at is, like I said, getting even better results than what we already have seen from Biddeford Pool. Get that one running, so people like yourself or the water committee, you could also do it by video, but see and understand that one. And be able to talk to the director of that place and say, did it work or doesn't it work? And what kind of headaches do you have and what don't you have? And then, develop more and more, because it is a safe, valid alternative to bleach. And you're doing it with something that you would normally up away. So we've got more brochures. If I can have your email, I'll send you some more.
Yeah, it's sludgy, SLUDGY.
Hang on,
I've been in wastewater too long.
Yeah.
That sludge.
SLUDGY.
Yeah, I'll give you this. You can write it down.
And while these guys are sharing information, thank you all for attending today, and we'll sign off in this, and we'll keep folks in the region informed as the information about this technology begins to evolve for us. Thank you very much.
Thank you. Thank you very much for putting this on. I appreciate everything you're doing on it. So I'm interested to see how it develops as well. So I'll be staying tuned.
Thank you, Orion.
Okay.
Thank you.
thanks.